begin? Because unfortunately, I have a fair amount to say, but Greg was busy taking care of his stuff, so he can just take care of that while I'm talking. As a way to fill some time. Welcome to the first evening lecture at the School of Architecture. I'm very pleased to have Greg Lynn as our first lecturer this year. We're also trying something new. We start at 5:30 or now 5:40. The reason being is that there is a reception. Did I say cocktail reception? Yes, happy hour, I can say. Legally, I can say that. It starts promptly at 6:30 to 7:30 because that's as long as we have them for. So we're already going to be late, but if you have to wander out and get a drink, feel free during that time. Just the facts, since 1991, Greg Lynn has been principal of Greg Lynn Forum, located for the last 15 years in Venice, California. Greg holds BAs in both architecture and philosophy from Miami University and MArch from Princeton University. Before opening his own firm, Greg was a project architect at Eisenman Architects, where, among other projects, he was the project architect for the Arnoff Center at the University of Cincinnati. Greg's individual build work includes the Korean Presbyterian Church in Queens, done in collaboration with Beth Garofalo and Mike McIntyre, the Cincinnati Country Day School, and the Bloom House in Venice, California, as well as multiple interior and installation designs, as well as a series of objects and products ranging from furniture to chess sets, flatware or not so flatware, to tea and coffee sets, to jewelry, and now even a yacht. An American type yacht, to be exact. A trimaran, which I guess must be better than a catamaran. Greg holds at least 3 concurrent teaching positions: a studio professor at UCLA, university professor at the University of Applied Arts in Vienna, and the Davenport visiting professor at Yale. He edited the paradigm-shifting Folding in Architecture from AD Magazine in 1995, and his books include Animate Form from 1999, his collection of essays, Folds, Bodies, and Blobs, a year earlier, Intricacy, a publication done in conjunction with an exhibition that he curated at the ICA in Philadelphia, and his most recent monograph, Greg Lynn Form from Rizzoli, 2008. In 2001, Time magazine named Greg one of the 100 most innovative people in the world, and I think it was in the 21st century they were really judging out. And 4 years later, Forbes magazine topped that by naming him one of the 10 most influential living architects. Greg is a recipient of the American Academy of Arts and Letters Architecture Award, the Golden Lion at the 11th International Venice Biennale, and a fellowship from the United States Artists. Now, before Greg was famous, he started out modestly in his first teaching gig here at UIC in 1991-92, when he was first hired by Stanley Tiger. I believe at the time Greg was teaching, hard to believe, a typology studio with Stuart Cohen, and also a first-year graduate studio which he did solo on the program of a beauty parlor. Greg was interested in beauty at the time. From the graduates of that wonderful studio right here. So although there was no such thing as the paperless studio in those days, here or anywhere else, Greg was already working on those problems, though in that case generating blobs and developed surfaces the old-fashioned way by cutting up potatoes and skinning animals. A note to Greg, we still do it that way here now. There's something about animal skins and carcasses. Obviously, right after leaving here, Greg would go to Columbia, where soon after he would inaugurate under Bernard Schumann the paperless studios at Columbia, and what is then clear to us is the subsequent generations of quote-unquote digital architects that Greg has really inspired and instigated and trained. I think what differentiates Greg's work and sets it above all of those successors is that it always began as a disciplinary problem in the field first, and only secondly, that was there even the technical capacity to do those things. So it was never a technical default, but it was always a kind of intellectual and disciplinary problem. In fact, in those first studios, Greg was partial to orthographic projections to represent a project, direct plans and sections. He insisted that models be no bigger than the size of a cat. And he was in huge arguments, adamantly opposed to people like Wes Jones, because Greg believed that architecture shouldn't move. Now 20 years later, this is what happens when you relocate to LA and they make a robotics lab for you. Things now move a little bit. One of the occasions for Greg's visit tonight is that he's one of the practices featured in the exhibition that opens tomorrow at the Art Institute. Greg's Stranded Sears Tower project has just been added to the collection there, and it's the project that Greg's is featured in the show. I thought I might give a little background on that project, since I suspect that it won't find its way into the official material. So by way of a little background of that, and I know some of you have heard this story before, but Andy Model assured me that he wanted to hear it again, so. Okay, this is for Andy. The rest of you can take out your iPhones or whatever. So back in the day, circa 1992, we had at the time what we would refer to as fun days, and by we I mean Greg, Doug, and myself. Now, unfortunately, the day of the fun, the institution of the fun day is no more. I think it's because back in those days we had neither email nor the internet. It wasn't yet invented when we were there. But since we taught studios Monday, Wednesday, Friday, that meant all Tuesdays and Thursdays when we weren't teaching were fun days. And a typical fun day for us would begin in Greg's apartment, where he would make up huge cut mugs, like bowl size, huge, of cappuccino, and Doug and I would bring donuts, which Greg referred to at the time as big jelly sleeping pills. And after an energetic discussion of architecture, which lasted probably about 10 minutes, we would all crash from a sugar high on the floor and wake up a few hours later not knowing exactly what happened, trying to shake it off, and by then it was time to start drinking. I actually don't know when we had time to work. I suppose we must have done some work, but I do have the sense that we entered the field as lazy generalists, and now we're surrounded by a generation of overly industrious specialists. So, I guess we were lucky. In any case, it was that fall that Doug organized a faculty exhibit entitled Citation that instigated Greg's response to the Stranded Sears Tower project. In other words, you had to have a site in a word. Greg's word, I believe, was strand, which was like the beach, or the river edge by the Sears Tower. The moral here for the younger faculty is that even a seemingly modest school exhibition may one day end up in the collection of the Art Institute, so keep going. Basically, the project is a monstrous tangle of threads along the Chicago River. You have to understand that at the time, Greg was under the sway of Allison McLean, who had done a kind of short horror film called Kitchen Sink, which you should all rent and look at. It's really disgusting. But a woman who pulls a hair out of a drain in a sink, and all of a sudden it becomes a big tangle, and becomes a big guy, and it's this big mess. In any case, Greg had this mess of a model, which was more like a big cat fur ball than a cat per se. But he had it on a small site model in his apartment, and while he was working on it over the break, and he went back to New York, back to Hoboken for the break, and Doug and I had keys to his apartment to look after things. And Doug had the idea that we should really just simply make about a 60% size model of Greg's site model, so that when Greg got back, he would think that it had grown. It seemed like a good idea at the time, and we weren't, very busy doing anything. And so I think Greg came home to find that, although I suppose the giveaway was the Dunkin' Donut box on the floor. But I would say that to me this is the birth of animate form. Whatever the history books say, it started as a practical joke. I was at a conference last November where Greg gave what I thought was one of the most interesting and telling presentations, and he said that we still haven't, in some ways, moved beyond those projects that were done in the pre-digital, quote-unquote, era, in the kind of era of the paperless studio, and particularly named two 20-year-old projects, Eisenman's Max Reinhardt House and Koolhaas's Je suis Library, and said that we're still working through those issues, and there really hasn't been anything that's, in a certain sense, gone beyond them. And I think that that was an interesting challenge to many of his own successors, and maybe something to talk about. Among his many other achievements, Greg has done the most to reconfigure and conflate the categories of art, architecture, and design in practice, and at the same time has been one of the most forceful voices in maintaining their distinction in theory. I look forward to his further continuing, conflating and distinguishing those things tonight. Please welcome Greg Lynn. Welcome back.
everything Bob said was true, but he left one important thing out, which is when I came to Chicago, I told Bob that I had, I forget what my budget was, maybe $600 a month for an apartment, and asked if he would find me one. He says, I got you a great place. And I went there, and it was full of flight attendants. It always smelled like pork chops. They always seemed to be cooking pork chops, and my apartment was fine, but the windows in it were only about 6 inches wide and 4 feet tall. I think I had 2. And so all I had to do in there was draw. I mean, I felt like Barton Fink in that place. And when I was here 3 years ago, I was in a taxi and went by Melrose and mentioned to the taxi driver, oh, I used to live in that building. And he said, oh, that's a building for blind people. That was built, see the monks with the German shepherds is Carrie Abbott's on the front of it. I'm like, yeah, I never noticed those were German shepherds and monks. Yeah, those are seeing eye dogs. That building was built for blind people. So I think that was the most, I was like a mushroom for that year in Chicago, in that place. It's really great to be back. It's really strange to be back without Doug, and so it's the first time I've been back, and the church that I did with Doug and with Mike was, a very pivotal thing for me and a very, I think, transitional project for me. We were all kind of way in over our heads in terms of scale of the project, and what was most interesting about it is it was really on that cusp between things we wanted the computer to do already, and I think that's why the Sears Tower for me, it's very kind of, what's the right word? Well, it's just very sentimental for me to be back and have the Sears Tower drawings in the Art Institute, because that, at the time, I knew was the last project I would ever draft 100%. I mean, I even did when Doug and Stanley posed the show, I thought, you know what? I'd worked for Peter where we had computer plots as underlays and drafted over them, and then would draft our geometry and send it to the engineers to give us the digital 3D document so we could control construction. And I knew it was at a transition point, and I thought, well, just because I love to draft, I'll do one last project as complicated as I can, drafting, and that'll kind of be it. So the church was really, came soon thereafter. And I think it's not really the legacy of the technology, the transition of technology, but really a transition in sensibility that I think is still very much around. And so the first wave of digital technology, let's say, for me, adopted the tectonic impulse of architects and added to it the complexity you could achieve with a computer. And I think only an architect would look at a computer and say, well, I used to build with 10,000 elements. Now with a computer I could build with 100,000. Or I used to have details which were modular. Now I can have all my details unique. Only an architect would ever do that. I mean, anybody else would be considered retardataire if they did that. Like if you went to, say if you walked into Vitra like I did once with 3 designs for a chair. One of those designs I said, look, typically you build a chair out of 10 or 12 parts, legs, arms, back, seat. I've got this design, but we're going to build it out of several thousand parts. And everyone will be unique. And I got this look from Rolf Feldbaum, like, what are you, an idiot? It's the best thing you can come up with to use a computer for, to make all of our lives more difficult, and then come in and save the day and make it simple again. But anyway, I realized at that point I wasn't being innovative at all. He was seeing me as very retardataire, and maybe it's important to be retardataire. I mean, maybe that's what makes architecture unique, is that we fetishize details and we make things overly complicated. But anyway, I for the last few years have tried to see what it would feel like not to do that. But anyway, I think the first wave of digital technology was really about increased complexity in the best sense and increased complication in the worst sense. and it manifests itself in a celebration of details, and in some cases a fetishization of details and connections. And it also involves an increase in layering and superposition of surfaces, where once one surface would do, now you might have 3 or 4. And that also has something to do with postmodernism, probably. So, the church for me was really Doug's and Mike's and my response to that trend, and there was definitely a desire to smooth some of that tectonics. But, every structural member was unique in length and angle, and back then we even had to do all of the dimensions for the steel. Back then, all of the interior surfaces were unique in angle and orientation and surface. It was really, an attempt to take what would have been a modular tectonic and try to push it into some variation, let's say, of elements. And here, there was always the desire to produce an effect that was continuous and smooth, however. I would say, and I'm going to run through this really quick, that for me anyway, in my autobiographical experience, the second wave of digital technology was CNC controlled shop equipment and tools. So primarily CNC routers, laser cutters, 3D printers, things like that, which also allow for a high degree of customization. And also the loss of the need for certain kinds of drawings, potentially. And I think a byproduct of it is it introduced concerns of construction and craftsmanship, where I know in my own experience, I started to work like a contractor. I mean, providing design services that would have been outside the scope of typical design services, and even in some cases, doing mock-ups and prototypes and things like that. And again, I mean, curiously enough, oops, what did I do? I'm gonna hold it again. With the church, it was the first time we came in contact with that when we were ordering pews, well, pew ends, like the the only thing we could really customize were the ends of the pews. And we had, maybe 10 different catalogs from pew end manufacturers, and we found out there was one company in Arkansas with the CNC mill, which cut them all and supplied them to all the distributors. And so we said, well, if we give you an Adobe Illustrator file where every pew end is different, can you cut them all different? And they said, yeah, no problem. So that was, for me, the first contact I had with CNC. But so that impulse, for me, started to bring in a language of surfaces and an integration of tectonic elements with surfaces. So here in Pretty Good Life showroom, the shelving, posts, I was trying to integrate and make disappear into the surface through the tool paths and things. This is in the mid-90s. But the logic was starting to become one of surfaces. But the construction logic, for me anyway, was still very tectonic. And the same thing, this is the Uniserve headquarters in downtown LA. Similar kind of thing, using plastics and things, which have later become important for me. The last gasp, I think, of the tectonic, for me anyway, in terms of research, were these studies with hollow plastic bricks. And it was really Nadir and Monica and what they were doing with bricks. And then also when I left the ETH, my assistants there started to do some really interesting stuff with bricks, like Matthias Kohler. I thought maybe masonry is something I should think about in terms of language of construction. And so we came up with this idea of hollow plastic bricks that would be kind of lightweight and modular. And we built, I don't know how many tens of thousands of things we've done over the last 5 years, but lots of these bricks that we designed. And a CNC arm cuts each one of them uniquely so that we can array them digitally and find their intersections and then cut them. One of the interesting things is the amount of labor that goes into assembling them, which is massive and sometimes catastrophic when you get students involved. So, but I mean, this is the biggest thing we ever did. We did this dome at SCI-Arc, where we had teams of students in corners building towards an oculi. And you can imagine when we came together how we didn't come together. But it gets really important to have a measurement control and a jig and that kind of stuff when you start to deal with this level of uniqueness. And even when we mold, when these are molded, just 5 degrees in temperature when they're molded, or even different colors, can result in a ½ inch difference in the bricks. So when we cut them all up, there's actually not a lot of accountability for tolerance in them. Anyway, so this kind of thing I started to sour on in terms of super complicated, unique, custom components assembled together in an intricate fashion. This is kind of where the idea came from, but then I couldn't do it because I couldn't get enough of the toys. So over about 5 years, we got all these toys as bricks till we had a few hundred of them, and then we started using those instead. That's a little duck, German duck. And then we did this furniture out of these, and then eventually fountains. So anyway, for me, in all of these modes, there's always a primacy of geometry, and a primacy of geometry in the form, in the tectonics, often in the structure. Like at the church, the center line of structure was always the isoforms or the loft lines of the surfaces. So there's always a translation of the geometry and the lineaments directly into material and structure. And something totally accidental hit me when working with textiles, which is there's a paradigm out there of construction that comes from primarily composite construction, where the structure and the form are totally disparate. They're integrally related, but they are not the same things. And more systems, let's say, are integrated into fewer elements of construction, while at the same time the systems and the structure themselves get literally microscopic at scale. So the term that people use for that is load path structure, which is no different than calculating the load path of structure in an architecturally conventional way where you chase loads down through a frame. The difference is in composites, some method of analysis, usually finite element analysis, gives you load paths on surfaces or in frames, and then the structure is placed at a fiber level along those load paths. So instead of dealing with fibers that are, 2 feet square, you're dealing with fibers that are, a couple of millimeters. But what that does is well, I'll show you hopefully what that does. The first thing where I learned about this was in this carbon crystal sail project with Swarovski, where Swarovski said they wanted to use crystals for interiors. They wanted to come up with an application to use crystals as a building material. And like a lot of people, I had seen these Prada ads around 2002, 2003, where Prada did this ad campaign with North Sail's carbon fiber as a background to all their ads, and it was because they were sponsoring the Italian America's Cup team. And I know, like Renzo Piano ended up draping a building in used sails. Lots of people saw those and said, that looks like architecture, and I saw it and I thought that should be architecture, and I was drawn to it because of the geometry. So I worked with Bill Pearson at North to build these crystal-coated lightweight membranes for the Swarovski Pavilion at Design Miami, maybe 2006 or 7, something like that. the way they're made, one of the things that I was drawn to the technology about is they have a very big CNC controlled mold. So this is a deformable mold that jacks into different shapes. And they're what's called the flying shape of the sail. So the shape you want when you put the sail up is a shape that it's molded on. And there's a gantry that draws fibers on it. And then we with 11 by 17, again, those people with 11 by 17 place 3 million crystals on the surface. So the mylar goes down, a level of these carbon fibers are drawn across the surface with this head. Then the crystals are transferred on, and then another layer of mylar goes on it, and then it's cooked. It's back and back. So the fibers all are what you call pre-pregged, which means they have resin on them already and they're frozen. And so I don't have a picture of the broiler, but the fibers go down, the crystals go down, it's put in a sandwich of mylar, and then a thing like a broiler drives around it robotically and cooks it while it's under vacuum pressure and pulls all the glue out. But so at the time, this was the lightest, strongest material at this Gossamer scale. So it was lighter than paper, but one of those surfaces could hold maybe 3, at that scale, maybe 3 to 5 tons of float. So incredibly light and strong. That's why the sailboat industry is the only thing that really needed it at that time. Anyway, when it gets all cooked down, you can see it's all consolidated into a single sandwich. And that's the gospel of composites, is sandwich construction, where you put multiple elements together and cook them together in a sandwich and consolidate them so you can take advantage of their properties, whatever kind of properties those are. And this is all supported on a carbon reinforced aluminum frame. So and the idea is they could pop up and down really quickly. In practice, it took a day to do all 5, which isn't so bad, but we thought it would be easier than it was. But this also, I've been trying to look at the logistics of this kind of stuff so you don't throw it away, but so it gets reused over and over again. Maybe show later some examples of that. But anyways, the crystals is an array with these different patterns and surfaces were located in these load paths. So everywhere there was a stress, you would locate the fibers along that stress. And it was totally arbitrary to the shape. So, the shape is what generated the stresses, but the structure did not follow the geometry of the surface. It followed the load paths on that surface. And that freedom of structure and form being disparate, I find very provocative. Okay, and in all this and hanging around with these kinds of people, you realize what they hate more than anything is metal. They hate it because of corrosion, and they hate it because of its inefficiency due to its weight. Steel's great, it's easy to form, and it has a good modulus in terms of structure, but it's, for its weight, more expensive than carbon, more expensive than a lot of fibers. And so more and more I've been looking at things and trying to eliminate both metals, but also more than that, to eliminate mechanical methods of attachment, like bolts or nails or screws, and instead use glue. Like, I don't want to be in a car or even a plane. Like, if I get in a plane and I see rivets and bolts, I get nervous, because that's an old plane. They don't hold planes or rivet planes anymore. They're glued. Everything is glued. Your car, all glued. Like the bolts on your car door are just there to let the glue cure. Like, you can go drill the bolts right out, no problem with your door. It's not going to fall off. Your car is all glued together, unless you have things you need to take in and out. And even that stuff is getting glued together. So I find, when I see somebody do a carbon fiber wall panel, and then put a big metal angle with a plate and bolt it together, it kills me. So I've really been trying to figure out how to exploit chemical construction rather than mechanical construction. And again, that's germane to what you call quasi-isotropic structures, which are structures which behave both in tension and compression and with, let's say, a fiber-based construction. And it's for sure the case with composites, which really, composites just means different materials together in a matrix, but in rigidized textiles, like Spectra and carbon and things. Again, Chicago with the hyperlink show. Joe Rosa and Zoe Ryan asked if I wanted to do something with furniture, and I decided I wanted to take the next generation of that sail construction and look at chairs which were both compression and tensile structures. And what's nice about this, well, what's nice is you get to say it's the lightest chair I've ever made in history. That's cool. But what's really nice about it is not that, it's that because of its lightness and strength, it holds a compression shape when nobody's sitting in it. So when it's just hanging in the room, instead of looking sad and droopy, like, sorry, but like, when I see a Candela dome, it just looks upside down sad to me. You know, it's this kind of hanging, sad shape, and all the hanging chain models, even Sagrada Familia, just looks sad. And it's upside down sad. When you look at the chain models of Sagrada Familia, it's just depressing. It's like, look at that sad hanging thing. So it's why my whole life engineers have always said, we should do that in a tensile fabric. And I just say, no. Like, first of all, I can't discipline the tensile fabric because I've been down the line that engineers will always tell you it's got one shape and the shape is determined by the material. So whatever the curve of a tensile roof is, that's the only curve you're going to get because you cannot shape that material. And it's a sad shape. If it was a good shape, maybe that would not be a problem for me, but I find cat it's very depressing in an aesthetic level. So this is molded, it's on a mold, which is important. And when it's hanging, it's in compression, and so it holds the shape of the mold it was made on. So these are all hanging compression shells rather than hanging textiles. But the minute you load them, they convert from being a compression shell into being a hanging textile structure, hanging tension structure. So, and we had at New Year's Eve, I think, 900 pounds of architects in this particular one. And it was a real light. So it weighs about 5 ounces and will hold 1,000 pounds. And you can also put it in a FedEx pack. So you don't need to store it. Inventory is not a big deal. Shipping is not a big deal. But really what's nice is you get the ability to have a thing which holds a shape but is still a textile. It's built out of tapes. So this is carbon and Dyneema tape. And they're parallel, you can call these unidirectional fibers. And then you locate those tapes, again, where the major loads are. So there's, the latest one we made had just 3 layers of tapes at 3 60-degree orientations, just so you would put your finger through it. And then maybe the lightest one has about 10 or 12 layers in the corners where the loads are heavier. And this is how it's built. You locate those, you take the tapes out of the freezer and they get tacky and you lay them up on mold. You can do what's called a preform, where they would all be pre-located on like a transfer sheet if you industrialized it. And then you put it in a bag and you put it in an oven, but oven's too strong a term. You heat it to about 180 degrees and pump all the excess glue out of it to keep it light, because the glue is just parasitic weight. Anyway, the mold surface always looks better than the bag surface. And we did, this is 100% Arabic, which is just a different fiber. So this, this kind of thinking about composites, translates into flat construction as well. But the one other thing is, the connections. This is Spectra, or Dyneema is a trade name for it, like Kleenex. But whatever you want to call it, it's an ultra-high molecular weight polyester. And we put release sheets in the corners, so after it was molded, we could take them apart. We just spray that and put it in and glue it with 5900 glue. And that little, I think it's 1 mil string, each one of those will hold a ton. So instead of having like some metal rivets or hooks or some ugly Pier 1 type detail, no metal. I'm very into textiles lately. Just to, to talk about some of the logistics of this stuff and the sustainability of it. The Index Awards, which are the biggest design awards, I don't know, most architects don't apply for them, but they're a very big design award, bigger than the Pritzker Prize, and they're given for things that improve life, which translates more or less into sustainability. And I have 5 categories. They have 10 or so finalists for each of those categories, and a winner in each one. And it's sponsored by the royal family in Denmark. And there's an award every 2 years in Copenhagen, and then they take pavilions and travel the finalist objects around the world at all kinds of design fairs. They were in Chicago a couple of years ago. And they get set up for a week or two, and they travel to at least 9 cities a year, sometimes more. And anyway, they get vandalized. They're complicated to assemble typically, and they take a lot of fuel to ship around the world on boats, occasionally even on a plane. So they asked me to design the pavilions, I guess now 3 years ago, and they gave me a budget and we started working, and all they could talk about was vandalism, especially in Northern Europe. And as we got talking, they kept talking about the logistics of it all. I said, what does it cost anyway to make these things? And I think I'm not really supposed to say the numbers, but so if it's 1x to make the vitrines and the pavilions, it turns out for 4 years it was 6x to crate them, ship them, assemble them, and repair them. And so I said, look, I could prove I could knock down 6x, but I take some of that savings and throw it into the fabrication. And I said, sure, we're game. They also, because they're in Copenhagen, they love wood. And so they said, please try to do it in a sustainable hardwood like plywood. And so we did a design with plywood. It was going to take 5 or 6 containers. It turns out they previously had done an exhibition where the pavilions took 12 shipping containers. So we ended up working with carbon. And these are all carbon reinforced plastic sheets that get cut, and all the holes are there because they're translucent and kind of visually lighter, but also they're physically lighter. And forgot to bring the video, but they're online. You can see a video of them mounting and demounting them. But the little ones, one person can even do. But 2 people can put one of these together in 2 to 4 hours maximum. And all the boxes are all plastic cord aluminum, so they fold and unfold flat. And all the panels lift out in sections and interlock purely with friction. And there are a few bolts to just bolt the thing down to a base, is all, which we fill with water and dump. But otherwise, the whole thing is held together with no mechanical connections whatsoever. And so 9 of these things fit in 1 shipping container rather than the other way around. So by looking at the logistics of it, it turns out we're much lower carbon footprint building in 60% fluorocarbon. So I think if you look at those materials, you say to somebody, you want to build it in bamboo or you want to build it in carbon fiber, they'll say, well, bamboo's good, carbon fiber's bad. But when you look at that bamboo getting shipped from Thailand, where they're deforesting to give you cool bamboo floors for your sustainable clients with their recycled jeans, insulation and stuff, the real footprint of that, when you look at the whole supply chain and logistics, is really a little bit focused. And in my mind, nothing can beat light, strong, compact. Like SF Moen right now with Snowhead is doing composite wall panels. They're saving 3 tons of steel per 20-foot panel just by getting the weight out, and they're easy to erect. Anyway, so the whole logistics of this stuff is very interesting. Okay. The downside of all this stuff is you need to make a mold. The mold is usually something that gets thrown away. And so we've been trying to figure out some mold making scenarios. This was kind of the most clever. I work a lot with Bill Chrysler in American Canyon, California, up by Sonoma. And for the AIA convention in New Orleans, he was asked to do something in composite. And so we designed these lanterns with a reusable mold where we can pop both fiber-reinforced cement and a fiber-reinforced polyester skin off of the same mold over and over again. So with this one mold, we came up with these kind of funny shaped rings, and they'll cast the cement-based polymer in this section, pop those all off, leave the molds on, and then cast the kind of translucent polyester, and then assemble it all after the fact. So one mold is being used to manufacture disparate materials that then get assembled together. And that autonomy of molding and surfacing, for me, really has become kind of a mantra, which is a surfacing. And this came out of that Vitra experience. And thankfully, when I presented to Rolf the 1,000-piece chair, I also had the other end of the spectrum of proposal, which was the 2-piece chair, which they loved and built. So and for me, they thought it was innovative because it was reducing components and reducing assembly time. So for me, if you can reduce components, it's a kind of automatic sign you might be innovative. I think if you increase components, it's probably a sign you're either standing up for the values of architecture or being retarded. I think the other thing is not just one of assembly, but it's about having multiple orientations of the same surface. And I'll show you some examples of how that's maybe a bad idea to go in that direction, but it's a direction that I'm interested in now, is how can something be built with more than one orientation in mind, without having to change the surface. And then finally, that you can build intelligence into surfaces. I think ergonomic, it's just because it was furniture. So for the ravioli chair, the idea was a 2-part chair. There's, in the end, more parts than that. But the base is a composite base, which is very lightweight. They actually have to ship it with lead so that it's heavy, because people don't like light chairs because they slide when you sit on them and get up. So there's, it's ridiculous, but we ship lead around the world to make them heavy. And then the top, it really started because they were showing me around the factory before we ever did the design, and all their office systems chairs were 3-dimensionally knitted with computer knitters. They had like little socks, and they would pull the socks over the back of the seat, and it was easier for them to reupholster, more efficient. So this, we did a 3D knitted top, which is like now like the Nike Flyknit shoes. Same thing. I think a lot of the textile industry is going towards knitting rather than weaving. And so here there's 2.5 times as many fibers or knots in this section as there is just 8 inches away in that section. So it's like, I don't know how to say, it's like a bra. I mean, it's like the hanging chair. It's three-dimensionally shaped before it's upholstered on the surface. So you don't have to fight it with glue and seaming and upholstering. It's a 3D knitted shape for a 3D surface. And the idea was to get rid of legs and seat and back and to just use a hard surface to be the structure and a soft surface to be the ergonomics. Same thing with the Alessi coffee and tea towers. Alberto Alessi gives this great tour to all the designers where he kind of lists 5 values and tells you if you can do any 3, you'll be a success. But if you only do 2, you'll be a failure. But he loves failures, actually. The most interesting stories were the failures. But it's like if it's cheap, unusual, and an unknown typology, like Philippe Stark's lemon juicer, it's a success. Or if it's highly functional, cheap, and shiny, I forget what he calls shiny, it'll be a success again, which is the Rossi stuff. So anyway, he ran me through this, and he then said, well, just put handles on whatever you do, because architects refuse to put handles on their stuff, and people always burn themselves. And the first iteration of Graves and Meyer and Rossi, and all these people he listed had no handles. And he said, we had to go put handles on for the commercial stuff later. So I thought, okay, I'm gonna make it all 100% handle. So these are coffee and tea flasks, and on the inside, like with the Turkish coffee cup, there's a titanium flask, and then bonded to that with silicone are 2 titanium skins. And so you can grab it anywhere you want and not burn your hand, and it's all, I don't know how it's made, but it's, it invites you to grab it. And the commercial version of that, the supple cups, is the same thing. It's like literally like 120 little handles all the way around. And then the inside is the cup, and the outside is all handle. So instead of having a base and a cup and a saucer and a handle and 5 or 6 elements, it's just one shell. Like one surface does all the work. And same thing with this, 4 surfaces do all the work. And the base also, which we forgot to do at the very end, is reversible. So when you have liquid in it, they notch in like this, and these things act as feet. When you're not putting something in, you flip it over and lay the things on their backs like a flower. And that's actually the 5 people that bought it. That's how they always display it. If you want to know that economics, they gave me $45,000 a set to make them because they wanted to make them in sterling silver from 3D prints. And I went to it was before the internet, I found in Yellow Pages, high-tech welding, and they make them for $4,500 a set. So that's a $41,500. Or $40,500 profit margin on these things compared to some poor schmuck making them in sterling silver. But anyway, that's why they're so expensive. Same thing with Swarovski. We did, what I consider a composite element, a lot like that lantern that we did with Bill Chrysler, where 3 materials end up occupying the same surface. So the crystal, its setting, and the ceramic setting, which is what touches your skin, all occupy the same surface. So this idea of having something monolithic, meaning like one descriptive surface with somewhat arbitrary transitions of material on it, this is the smallest scale we've ever gone with it. Okay, so the boat thing. Because it's so close right now, I have a lot of pictures of this that I'll run through really quick. But for me, this has been an experiment in building scale construction and learning about the principles of materials. I really got back into sailing because of the materials and what's I think of as a very steep innovation curve that's going on in the world of high performance sailing right now. It's much more rapid in innovation than Formula One or aerospace right now. I mean, if you look at SpaceX, it's pretty much Apollo technology with a Silicon Valley entrepreneur kind of do it affordably, but there's really nothing new going on that I can see in the aerospace world in terms of materials or technology. Maybe in flight control, SpaceX is doing something new, but it's 1960s technology when you get down to it. Whereas in the high-performance sports industries, like Formula One, there's a lot going on with those tapes, but in the sailboats, it's affordable. I mean, affordable if you think of it as a building. Like, if you measure this, its per square foot cost is the same as an expensive house. Like, the highest tech, like Larry Ellison's boat that just won the America's Cup yesterday, per square foot is about the same price as that's because it's so big, kind of a mid-level house. So it's amazing to me that you can build this for the same price. You build something with, CMU blocks and some nice interior millwork. But so this project involved me kind of adopting a naval architect in the office, and he's one of the best ones in the world since Frederick Berubla. And this industry is really in a huge slump. Nobody's building high performance small boats right now. So Fred, who started working with me on all of the composites as an engineer, ended up working full-time with me in the office, and we kind of worked on this project over the last year and a half or so, kind of on the side. But what it involved was, I mean, for me, thinking about a surface which is moving and reorienting, and with Fred, thinking through surfaces which are always analyzed in terms of performance. And one might think, if you weren't intimate with the way these things work, that there was some kind of science involved in designing a car or a plane, there's none. If you look at a Formula One car right now, they're not even really designed. I mean, there's 20 or 30 aerodynamicists that are looking at every part of a Formula One car, and they take that shape because somebody's working on a fairing somewhere, and that has repercussions on other parts of the car. If you go down a certain path, there are consequences, but at a fundamental level, somebody can come along and rethink the whole industry quickly, which happens in sailing all the time. So for me, it's really a stylist. Like, let's say a stylist who's a good sailor. I can make contributions to the design and chase them down with computer analysis. And because I made all kinds of promises that this will be published, I got access to the best fluid dynamicists in the world to do experimental stuff, because if I flip over and die, it's not the same as Larry Ellison does. So what we did, this is the first time they've coupled air and water analysis at the same time. So you take geometry, the rig, and the power, and the hull with all of its drag, and you put that into an environment and look at the effect of both air and water interacting simultaneously. And every time we would change shapes, it would have consequences that we could then iterate through. Because we had about a year of doing this. I mean, this analysis took a 60-some computer array about a week to calculate each time. So you have to be patient. Yeah, I mean, it's like the old days of rendering, where you send something off and wait a week to see if it works. And so for all of these shapes and forms, they have dynamical consequences. It's just a quick little playthrough. This is, everything that happens is wrong because there's nobody driving it. I mean, if you just trim the sails and put a boat in the middle of the ocean, just let it go, you can imagine it's not going to go very well every time. So everything is always wrong, but it always tells you, where you're headed with it. You always get information back. And I would then get the information back like this, which this happens to just be showing where flow separation is or where drag would be. And so we would then go through and re-log surfaces to try to minimize all this drag as much as we possibly could. So all these shapes, have performance associated with it. Like this curve, right there, which nobody's ever done in a boat before. There's another curve that runs along here. Those are really there so when a boat dives in the water, it can pop back out again like a nightshade. And it's also there so that when the boat dives in the water nose first, it's like a blade here, but then there's a lot of reserve buoyancy up here so that if things go bad, you've got all this extra flotation in the front end. So accommodating all those performance things, and this line is there so that when this spray comes out, everybody doesn't always get so soaked, so it sheds the spray off to the side. So all the lines and surfaces have an assumed performance, but there's no science to it, because the computer lets you iterate through and see what the consequences would be. Okay, so the first thing for me that kind of got me started on some motion thinking is that and the boat it'll go a little over 30 miles an hour, and it'll be very bouncing, and it'll change slope by about 15 degrees or so. So in thinking about the interior of it, we were thinking about all the surfaces as being reoriented. And for a very short time, I was, I guess you could say talking to, I was getting paid to talk to the biggest boat builder in the world about a line of boats. And Philippe Stark had done a line of those boats in the late 80s. And they told me a story that Stark came, went through their factory, looked at their boats. They hammered out an agreement, and Stark said, okay, well, the one thing I'm going to need to get started is you're going to have to deliver a boat to my garden in southern France. Well, they said, we're going to have to deliver a boat. And they said, oh, here we go, wants a free boat. He said, no, I want it in my garden. And they said, why do you want it in your garden? He says, well, I don't know anything about sailing, but I need to learn about what it's like to be in the boat. And so they brought the boat and set it up while he was gone, and he came back, and he called him, and he said, his boat is standing up straight. They said, yeah, that's how you store a boat. He said, but is a boat ever straight? And they said, well, not really, it's usually tipping. He says, well, come back and tip it. And so they built a special, cradle for it. So it was like at a 15-degree angle in his backyard. And supposedly he slept in it, and cooked in it, did everything in it at an angle in the backyard. And honestly, his boats are pretty good. And he was the first person involved in naval architecture to ever say, rotate my space because I want to see how to design it when it's on the slope. So they told me that story. I started thinking about how interiors would be different if you thought about them in motion. So this is a kind of schematic of what the inside of that main hull is like. This is all the furniture that we ended up making in our office to supply to the boat builders. And it's, the equivalent of a California king bed and 2 berths, couches and a little galley. There's a bathroom in there that's not in this photo. And weight is a really big deal. All of this, all together, this weighs 15 pounds. Like my 10-year-old kid can lift up this couch and hold it with one hand. So everything's crazy, crazy light. But it's also ergonomic, and all the details and things are all integrated into the surfaces. So the whole, the extreme quality of building everything into one shell, is really what the whole language of this stuff is. You can see it's all, paint that Fred, the naval architect, said to me. I said, well, we should just paint everything. He goes, do you want to go and erase the whole thing with like 5 gallons of paint in the boat? And so we only paint the least amount of stuff we can, but just some of the stuff you see. But anyway, the language of all of this stuff is a language of integrating elements to get rid of mechanical details. Like even the hinging and stuff like that, there's no mechanical hinges anywhere on the boat. And we aggressively try to get rid of all the mechanics. Anyway, I only threw this in because I don't know when Paula did her mutant material show, but I remember aerogel, just to get how rapidly stuff changed. I remember aerogel was like the gospel for architects. GSD had this aerogel studio, $10,000 in window to insulate with aerogel. And we were doing a cooler, which we really fight about because I want my wife and kids to come on the boat occasionally, and so we like to drink beer with the race. And so I wanted a cooler, and the naval architect didn't want to have a cooler, and it was the last thing to get done, and we found out we couldn't fit a beer standing up in the cooler. We just used normal insulation. So I said, let me just check what aerogel would cost. And so I went to aerogel.com, and I think it was $45. I bought all this aerogel on the thing. So what was the most exotic thing, became, totally everyday now in a decade. Anyway, the molds for all this stuff were all, unfortunately, custom milled out of blocks, like subtractively. They get coated and waxed, and most of them are reusable. Some of the ones that have dialogue, this is for toilet paper, that has dialogue, so you have to break the mold to get it out. And you laminate up 3 times. You have to vacuum bag it to keep it white. So you lay the fiber down and you vacuum bag it to consolidate it. Then you put a core on it, and then vacuum bag it, and then another layer, so it's a little super thin sandwich. Then they get painted, then we weigh everything. Okay. But if things weigh too much, we just sand them. And we've tried to eliminate all the metal. Everything that we made, there are 3 pieces of metal on the entire boat, other than the hardware. This is really like the enemy. Like when this box came in, it was really depressing, weighed like 60, 70 pounds. But most of this stuff is metal, but even here you can see, all of this is nylon, like high strength nylon. This is a fiber reinforced injection molded plastic. Those are Delrin bearings instead of metal bearings. So even in this world where they're having to deal with metal because it's a cheap material to use, in all the high strength areas, like the bearings, where you think the most load is, it's not metal, it's all plastics, it's all composites. And then where you would normally have, bolts with loops or things that are attached rigid, this is all Spectra. And like these things in particular now, because they hold the whole mast up, those will hold 13 tons. And that's like the size, it's smaller than my little finger, that Dyneema right there. So it's incredibly strong, and it's also flexible, so if the mast rotates, and that's why we have to use this stuff, is because it'll rotate mechanically, because it's soft. Anyway, so that's the rig, which is also all carbon. All up, the thing weighs a little less than 2 tons. Some of the construction, we supplied the builder with jig cut MDF. So for the things that are ruled surfaces, it actually was more economical to just build it as like an egg crate that they then door skin. And again, these things are really cheap. That's $2,500 of labor. Because you just throw that in somebody's house. And then again, it all gets vacuum bagged and consolidated. For instance, this is the arm that holds, there are 2 of these arms that hold everything together. And there's 125 layers of carbon in a stack right there that's all consolidated. So this is, crazy stiff, it's strong. Weight 9 times the strength of the equivalent of steel. These are the walls, bulkhead walls. Some of those got shaped. Again, they're all built as a sandwich. So all the kind of party walls, they get laminated similar right on a table. And then the molds for the hulls were all done with just a giant CNC router. So that's a 42-foot long piece of foam. It's surprisingly heavy. I know when we did the Venice Biennale in the 90s, we did this thing in foam. I didn't even bother to do a structural calculation. I just thought we'd hang it on the wall. And they called me from Italy and they said, it weighs 2.5 tons. How do you want to hang this on the wall? So this is actually, even though it's 1.5 pounds a square foot, it's anyway, and it's finished with almost zero labor. So the cost of the boat is about 30% to make the molds. Whereas here, by doing it in CNC, we made the project possible. So it just gets skinned in a quick layer of spackle, and then coated, waxed. And then you lay up layers of carbon cloth, This has a 1-inch core on it, which is then vacuumed into shape with a little bit of heat. And then another layer of carbon. And then wherever the basic carbon shell is what gives you the basic structure, then everywhere there are loads, you lay down these tapes of unidirectional fiber and patches, custom computer cut patches, and that's what the construction ends up looking like. So it's a 1-inch foam core, but then, that looks like it's maybe 6 or 8 skins of carbon, and sometimes it'll go down as thin as just 2. But all of the fibers are located based on the loading of it. And the load changes dramatically across the surfaces. But the shapes have nothing to do with the structure. Shapes only have to do with ergonomics from the inside out. Like the main hull is the shape it is just because we got to fit 3 people to go to the Y unit. And then the minimum amount of amenities. And then the other shapes of the hulls are really there for performance. There's a lot of craftsmanship fitting all this stuff. So only some of it is digital and precise. A lot of it is like almost cabinetry, let's say. Anyway, that's, but I mean, I see this now going directly into architecture. And for me, that's starting to look like the room of an architecture school or something. I mean, scale it up, triple, and it starts to get to be very architectural. The first thing we did with this kind of stuff is for Site Santa Fe, they wanted to do, redo the facade. So we did these scoop elements that plug into the existing facade everywhere. And then in the lobby, there's some elements that plug into existing passages and doorways. But these are all, they're composite shells. These are just all fiberglass. I think in terms of this ergonomic sensibility in the Bloom house, the idea when we started was that the client, Jason Bloom, said he wanted, complicated brief, lots of wall space for art, very cozy and intimate, and like a loft. And I thought, well, the loft and the art, I could see, or the cozy and intimate in the art, see, I had to do a cozy loft. It was not so clear. But as we worked on it, what we ended up doing was really building, it's like a row house. So there's no shape to it. It's just, if you inflated a balloon within the FAR, that's what the shape of the house is. It's just absolutely the maximum envelope. And the side walls end up folding and shaping to make a breakfast nook and a home office and a stair, and then over here the fireplace, and this steps up, and a shelf with a powder room, and then the kitchen. So the only door, there are doors here, but really all these spaces are made into spaces by curving and deforming these party walls. And then the same thing, the site steps, partially to get garage in, but also to give a feeling of a kitchen and breakfast area with an office, a dining room, and a living room. The change in height really is what gives that space the quality. And then to get it at a more intimate scale, the ceiling folds down and becomes this giant glowing lantern. So it was really about making an intimate but open space, like a new kind of long one, let's say. And then the windows and fenestration, I wanted to minimize the components again. So there's a stainless steel reglet that runs down the length of the house that all the windows kind of expand and contract to. So you can see, and that's that glowing ceiling surface, which is it's a composite, kind of oak-size composite. It's translucent, and also the first fire-rated composite in LA County. It's translucent. And then off-the-shelf things, like an off-the-shelf firebox and the sinks and things. Even these are just what you call cathedral windows, where the header is just flipped down to make a sill. So those are all off-the-shelf components that integrated into surfaces continuously. In the kitchen and the bathrooms, we worked with DuPont, like even when it came time to do like the drawer pulls, I was like, please no metal drawer pulls. And so that, we 3D printed a mold and then cast it in Corian, and it was $7 a pull. So kind of a little bit more than Home Depot, but a lot less than like Loom or something like that. But anyway, I was trying to get rid of metal in this house too. So the wet rooms, you know, that's all like a off-the-shelf Corian sink that then is put into a 3D molded Corian envelope. And then some of the furniture is built in, like the breakfast nook table and the kitchen island and stuff like that is also all formed. But again, it's about having a surface do more work. So the cabinet face becomes the handle, the legs of the kitchen island hold like the disposal of a lot of the equipment. And just trying to incorporate equipment into surfaces to make it clean and to give it that feeling of a loft while still having it be kind of cozy. Okay, so what Bob hinted at is the boat obviously moves and changes shape. I realized I backed into something. Turns out I did say I wasn't going to do it. In animate form, because I went back a couple weeks ago, but in animate form I said that if you use animation software, it need not follow that the building had to move. And I used the example of a boat, whenever that was, like 93 or something. I said the hull of a boat is designed to go upwind and downwind, all on the same surface. So two different orientations were, let's say, compromised or integrated into one static surface. And so in animate form, I said I'm using animation software, but not to literally make things move, just to imbue things with dynamism you couldn't have otherwise. But Bob is right, I had to put a moratorium on myself to actually have things be robotic or have things move. And I started backing into it. I mean, the boat obviously moves, but it doesn't really change shape. And so I would call that a projectile. And around a little bit after that, I was asked to compete for the thing that Anish Kapoor, anyway, the big red tower in the big park. Zaha and I were both asked to make a proposal, and I worked together with Christian Moeller to do this little robotic dome. And you can see there's, you know, that's Zaha's Notorium, and that's the stadium, and the site, which has a big red thing now, is there. We followed the budget and didn't occupy our site boundaries, which was the mistake probably. Did this little dome, with a little gold dome, and it sits on top of 3 columns, each of which has a Kuka. It's called a Kuka Titan, like a robot arm that can hold about a ton. And the idea was to build this all in carbon fiber to keep it light, and it would kind of follow everybody around. So, it's a really slow animation, so I'll have some water while you watch it. The Christian, I don't know if you know Christian Muller's work, but he does a lot of work with robotic arms that interact with crowds. So this would track where the crowds were, and it would provoke the crowd by moving around both slowly and quickly. So each of those arms lift up and down, and the ring lets it spin kind of endlessly. This was the first movie building idea. You get it. And then the last thing is, I was asked by Louis Vermeesch to participate in a building festival in Belgium in Kortrijk. And he asked me to do a compact domestic space. And he said there's houses were getting too big in Europe, people weren't living small. Could I make a highly functional, compact living space that was 600 square feet that could be for a couple? And he said it could be a workspace, but better if it was a house. And so I started, and it was while we were doing the interiors of the boat, and I thought, well, why not just do a house which occupies a 600 square foot footprint, but you roll it around to get, let's say, 1,500 square feet of living space on it, just like you would like with a boat. And so we thought about how to make it light so we could move it easily. We thought about the most simple kind of robotic mechanism, very similar to that London pavilion, to make it move. And the budget was modest, so we built a 1/5 scale prototype of it. We didn't get all the little mini furniture in there. But so it sits on a base that lets it rotate through kind of 3 orientations. And here you get a sense of how it moves. So it has like a 0 to 90 and a 180 orientation. And you see the ring that it's supported by passes through and makes these 2 columns inside. And again, it's a concept. You know, it would be for a very kind of limber and a limber and kind of well, like a couple that gets along really well, like people who don't fight for the remote. So each one of these are 3 cuts through it, 3 different orientations. I mean, I guess you call it a plan, although the plan rapidly turns into a section. But so you can see here, this is oriented for like sleeping and watching television. So there's a bed with nightstands and little, table with a small like seating couch on the kind of up the wall a little bit. But you'll see all this stuff like that table. The underside of the table is a light, and it sits in a volume so that if you have stuff on the table, when your house rotates, your stuff doesn't fall off, it just stays level while it rotates. So that's your dining room on the ceiling, and that's a dining room table. And so there's a table, there's a room for all the stuff on the table, and then the underside of the table is a light. So there's kind of actually 2 lights. One is put lights on the bottom of everything, the other is make a volume so your stuff doesn't get swept off. And the other thing is just, you can see here the closet is in a kind of a kidney that travels around, so your stuff in the hangers doesn't always get screwed up every time you roll your house. So that's like the 0 orientation. That's the 180, where it's more living space. But then here, the kitchen and the bathroom is all gimbaled and up hanging on the wall. And here you can see that's a section through the bathroom when it's gimbaled. And then this is kind of, that's for cooking. Realizing that orientation of it. And there you can see the bathroom's now hanging, sitting back out. But anyway, the idea was integrating furniture into the surfaces and building this thing as a monolithic shell, like an egg. So this is a little model we did for the National Academy Museum, where we show kind of all the furniture. This is not roboticized, but you can move it. So all the furniture and everything rolls around and routes in this one. These are the molds. We built it in 5 molds, I guess. So 3 molds for the kind of globe of it, and then 2 molds for the bones. And this is the stuff called GT. It's a composite, but it's pretty much skateboard wheels, stepper motors, hobby level robotics. And then this smooth animations, for me anyway, they don't look like architecture smooth animations, so we've always photographed it in stop motion, like kind of Godzilla style stop motion. But I think it looks more like architecture to me when it's jumpy like that. And so this is it. This was it at Cordrick, and without making too many promises, because it's pretty initial, but this has been up to Facebook for the last 3 months. And what's great is at Cordrick, it was all, kind of building and furniture industry people who all kind of looked at it like, what, that's supposed to be a house, whereas at Facebook, they're like, that's a house, and they all just jump in. And we have no more than one person in it, don't move it while you're in it. But I mean, at Facebook, all the 22-year-olds were like all over the thing, and want conference rooms and offices that roll around, as well as pavilions in the garden of their new headquarters. So we're working with Facebook to try to figure out how to take this kind of room and translate it into an office environment, which could have multiple orientations, and even, probably it'll end up just reconfiguring, let's say, rather than full-on rolling. But I'm hoping we'll get something that will actually just roll on a surface, so it looks like a wall ends up being a meeting surface or something like that. Okay. So sorry, I really badly kind of agree. You're better at parties than I am. You're better. Are there any burning questions?
Find Greg upstairs and ask a question.
Well, not everybody.
I'm sure he gets a great first.
Well, thanks. It's really great to be back. Really great.
Okay, we'll go upstairs and see Greg.